Bernie last night to see how things went, and I asked him how you did yesterday. He said, you know what, there might be a little bit of confusion when we're trying to determine whether two equations are equal or not. Would anyone agree with that? When you guys compared two equations, how I can determine if they're equal or not. Now, I'll give you a quick little example, okay? Just off the top of my head here. If I give you this guy, okay, and I give you this guy, oops, okay, you've got two equations. What could I do to determine whether they are equal? What's something I can do? There are many things I can do. But what's one thing I could do? What do you think, Adam?
Turn the standard equation into the y equals mx form.
Oh, I like it. So which one's standard form, guys? Which one's standard form? So he's saying take the standard form one, put it in y equals mx plus b. What if someone's like, ugh, I don't even know which one's which here. Which one would it be, Josh? The one on the right. Nicely done. Now, is everything in the same order that standard form typically is? Is everything in the same exact order that a standard form equation should be? What do you think, Eric?
Almost, but not quite.
Awesome. What could I do to make it look like perfect?
Move the y in front of the minus 1.
Awesome. So I could just do a little swap. Do I need to do that for this particular case? Do I need to do it?
No.
Not really, right? It's not going to change anything. But that's something to consider, is that typically we like to keep things alphabetical, okay, and by the degree of a term. Okay, remember degree of a term is what the exponents of the variables add up to for each term, right? So the highest degree terms go first. So if there was an x squared, he would go first, and then an x, and then a number, right? Something like that. In this case, we just go alphabetical, so we toss the y number, okay? That's typically what we do. But we don't even need to in this case because we're going to rearrange this thing anyway. Who can rearrange that for me? What am I going to do to rearrange it? We just did 2. What would I do to get started? Megan? Awesome. So she's saying, you know what? Let's get rid of these 1s. Check it out. These guys are gone. And we're left with a 1 on the right side. What else could I do in that same step? Now we're starting to do kind of like some skipping steps here. What else could I do to get myself a little closer? How about, anybody new? Anybody new? Andrew.
Subtract 2x.
Awesome. Subtract 2x from both sides. I'm going to do that over here. And we're left with, check it out, y equals 1 minus 2x. What's a more proper way to write that equation, folks? What's a more proper way, even though it's not wrong? Cam? Love it. There you go. Nicely done. So making sure we keep that negative and that plus 1. Nicely done. Now, are these two equations the same? Can I tell if they're the same? What do you think?
Yes, every term is the same.
Absolutely. All the terms are the same. Even if I left it like this, even if I left it in that previous step right here, I still know it's the same because I can see that those two terms can swap. So they are the same. Okay? If I wanted to do a table of values, all right, we would do something similar, except we'd have to sub in some values of x to see whether it's the same. Okay? And if we know it's linear, if I know they're linear, how many points would I have to check in a table to make sure they're the same? Okay, I'm going to say that one again. It's a deep question here. If I want to compare the table of values for these two guys, how many points do I need to see in both tables to ensure that they are the same, knowing that they're linear? So if I say to you, hey guys, look at this. These two tables represent a linear equation. When would I know that they're equal? So if I gave you a point like this, I know that these 2 points are on both tables. Can I tell that they're equal? Can I tell that those two lines are the same? What do you think, Andrew?
No.
how many more points would I need to tell that these two linear equations are equal? So this one up here might be y equals something. This one over here might be like 2x plus y equals something. I don't really know, but I tell you, they are linear. When will I know they're the same? Andrew Brown again. He says after two more. So he says like maybe this. And do you mean two more points like one in each? Or do you mean something like maybe this? Ah, nicely done. Why do I only need 2 points in the table or in each table to make sure that they are both linear? Why? Sorry, let me restate that. Not that they're linear. We know they're linear. Why do I only need 2 points to know that they are the same linear equation? What's going on there, Hassan?
Because they could just have one equal point.
Awesome. If I leave just 1 point, so if I back it up here and I take my eraser, if I get rid of these 2 points, they could still be lines, and guess what? That might be the intersection point where the two lines cross, right? So that same point is on both lines, but they're not the same line. However, as soon as I get 2 points in there, so as soon as I get these guys going on here, then I know, because they're aligned, if this is 1, 3 and this is 7, 10, I know that both lines must be right on top of each other. They have to be exactly the same. Okay, we're experiencing some more delay, which is wonderful. Did you guys have delay with Mr. Bernie yesterday?
Yeah, the internet was really bad.
Really bad yesterday?
We had to write. We wouldn't get on the note.
Oh, that's not good. Okay, I'm going to have to send an email downtown and see what we can do there. So something's a little wacky, but there we go. There's a point. Hopefully a line will come. But if those 2 points are on in both tables and we know they're both lines, then a line is going to be going through both. Okay, so essentially you're dealing with the same equation. All right?